Hello, my name is Kristen Bowman, and today I'll be sharing with you response time modeling for the size congruity effect, early versus late interaction. This was my thesis project, and I'm very excited to share it with you very quickly. So first, let's talk about the size congruity effect. This is a very robust finding that for participants to answer the question which number is physically larger, for congruent trials, it's a simple comparison. So we can see that the decision can be made that this 8 is physically larger and numerically larger for this congruent trial. However, just below that, I have an example of an incongruent trial where this 2 is physically larger yet numerically smaller. Researchers have found that these incongruent trials take longer to process than congruent trials. Well, why is this? It's said to be because of cognitive interference. So physical size and numerical value interfere with each other and require more time for the participant to decipher through the decision-making process. We have two accounts that try to pose where the locus of this interference occurs. So either it is in an early interaction account or a late interaction account. So that means either it is early in the decision-related processes, such as this shared representation stage here, or it is later in the decision-related processes, i.e. in this final decision stage right before output. Typically, researchers use an ex-Gaussian and a model to analyze their data, and they find a mean and a standard deviation, and they say, wow, incongruent trials do take longer to process than congruent trials. Yet, I was more interested in the locus of this interference. Where is this actually occurring in the decision-related processes? One way to analyze this is to use accumulator models. Accumulator models are said to be indicative of the underlying cognitive processes through 3 parameter types. So here is an example. We have 3 different parameters occurring here. First, we have drift rate, which is the ambiguity of the decision, right? So going kind of back and forth, gathering information along the way. This alpha is the response threshold. So this is the amount of information uptake needed before a decision can be made. And then finally, we have non-decision time, which is the encoding stage or the motor movement. Evidence for the early interaction account, we would see a difference between congruent and incongruent trials in this non-decision time. Whereas evidence for the late interaction account would occur in these decision-related processes such as drift rate and response threshold. So first, I took all of the data and I separated it by trial type, so congruent or incongruent trials, and then it was separated for each subject. So each subject's 2 trial types went through maximum likelihood estimation, or for most of our model types, and we came out to have 3 different parameters for each trial type for each participant. Well, then that was collapsed into grand means, and these grand means were compared to see if there was truly a difference in these parameters between congruent and incongruent trials. So the 2 first accumulator models I'll first share with you are the x-walled and the shifted walled. The x-walled is an exponentially modified walled curve, and the shifted walled is a constant shift to the walled. Here we have the 2 equations for the 2 types of models and 2 sample. I believe this was participant 43. This was what their entire distribution looked like. Because again, we're not interested in just a single mean and standard deviation. We're interested in the entire shape of the distribution. So you can see here I have 3 final 3 Bayes factors that were used to index support for one hypothesis over the other. So the most important piece of information here is found in drift rate. So this drift rate, notice we have evidence for the alternative over the null with these high Bayes factors. So this index support that there is a difference between congruent and incongruent trials for drift rate. And then the other ones we can talk about later. Feel free to ask me questions in the chat time. So the last model I'll show you is the easy diffusion model. So this is fundamentally different than accumulator model, but still poses the same idea that these parameters are indicative of the decision-making process. So we can see here that drift rate, we have, again, evidence for the alternative over the null in our drift rate. Critically, we do not have evidence for any models of non-decision time. Thus, one can conclude that we have evidence that the interference occurs late in the decision-related processes. So we have evidence for a late interaction account. We were curious about how and why this occurs rather than if it occurs. This is a very robust finding, and we were excited to provide evidence for the locus of the interference. Feel free to email me and ask me questions, and join me in the chat time later. Thank you. Bye.